Welcome to qnawire.
Interesting question. It asks about that for what values of c does this polynomial has have two inflection points or one inflection point and non-inflection point, and we have to also illustrate this by graphing p for several values of c, and how does c changes when how does the graph changes as c decreases. All right, so the inflection point is definitely the point where the double derivative becomes zero and the double derivative changes its sign. So this is the function. The first derivative is going to be p dash x, which is 4x cube plus 3cx square plus 2x. And the second derivative is going to be p double dash x is equal to 12x square plus 6cx plus 2. Now, this is a quadratic equation if we notice carefully, and we need to find the values of c such that this will have two inflection points. So, inflection points are nothing but the roots of the equation, and two inflection points means we have two roots of this equation. So, two roots are possible for a quadratic equation only when the discriminant is positive. One root of the quadratic equation, that is one inflection point, is possible only when discriminant is zero, and no inflection point is possible only when the discriminant is negative. So in short, we need to find a discriminant and equate it and behave and find these conditions. So let's find the discriminant first. That's going to be 6c square minus 412 2. So this is going to be equal to 36c square minus this is going to be 4 times 2 is 8, and this is 96. Let's see, can we take c common? 6c square minus 16, and now can we take 2 common? So that's going to be 3c square minus 8. So we are left with 6 times 2, which is 12. 12 times 3c square minus 8. So this is the discriminant. Now for discriminant to be greater than 0, in fact, what we can do is we can factorize this a discriminant over here only. So this is going to look like, let's take 3 outside as well. So this is going to look like c square minus 8 over 3. So this is going to be 36 times c square minus 8 over 3. So this is going to be 36 times c plus root 8 over 3, c minus root 8 over 3, using the difference of the perfect square formula. Now we are going to do the discriminant to be, in fact, we are going to use the sine rule over the wavy curve over here. So this is the number line. This is how the number line looks like. We have negative root 8 over 3 and root 8 over 3. So this is the region where this is positive, and this is the region where it is negative, and this is where these are the points where the discriminant is 0. So these will be the corresponding values of c. So for two inflection points, the range of c is going to be negative infinity to negative root 8 over 3 union root 8 over 3 to infinity. For one inflection point, the discriminant must be 0. So c is equal to negative root 8 over 3 and root 8 over 3. And for no inflection points, it means that the discriminant is negative, so that it has no solution. It means that the value of c is between negative root 8 over 3 to root 8 over 3. So these are the conditions for it to have 2 1 on no inflection point, and we also have to graph it. So we'll use Desmos over here. This is how the graph looks like, and this is the and we are also interested, we are only interested in the double derivative, how it changes its sign. So we are going to graph it. This is how the graph of f double dash x looks like, and clearly we can see that as the value of c approaches over to the negative side, it decreases, then the curve moves down, and there comes a point when it touches and then intersects the x-axis, and these two then would be the inflection points, because this is the these are the roots of the double derivative. And as c increases, it moves above, then this is the point where it has no inflection point, and this is the range where it has no inflection point. And then over to the right side, again it intersects, it touches and then intersects the x-axis, so again it has two inflection points. So this is matching with our algebraic solution as well, and this is how the curve of double derivative changes. And we can also make the same change, we can also observe the same change with the function. This is how the function is changing. So this is the change in the function, in the graph of the function with respect to as the value of c changes. Thank you.